So this video I will be covering some of the questions you can answer using this graph which I have built specifically for JVM. So it is this kind of representation, graph representation of JVM especially helps you when you are preparing for your exams or interviews. Time gap or to cut short the time you need for preparation, I have created this diagram. I generally use this diagram. You'll be asking why I'll be using this kind of graph, because I'll use this. I import this diagram in my graph DB. I usually use the NEO4J DB. So this is like our Neo4J DB looks like. Okay, so I have imported all. If you can see, this is the graph, and this has the all the nodes and all the relationships in the graph, and this is the query what I've run for displaying this. You can also import, and I'll leave that. So if I do the full screen of this relationship, you can see whatever I have drawn there, it has been here only. Everything is here. You can manipulate, you can check what all things are interconnected. GraphDB has very important significance have to play in our data science field, analytics field, real-time streaming also. It has been very much useful. Okay, so let's come to the question. What if you ask the question, what all questions this graph helps you to answer? You'll you'll have this image particular. You'll have this image like deeply rooted in your brain. Okay, so I have prepared some of the 20 questions which will be helpful for you to remembering the JVM diagram inside your head. Okay, so if you ask the question where JVM is loaded. So if you look in the diagram, the JVM or when JVM is loaded, sorry, it is saying when JVM is loaded. The JVM is loaded, and directly I'm going to the answer. The JVM is loaded by the JRE. You see the relationship start JRE when you run certain code. When you run have written certain sample code and then you want to run the code, then the JRE will come do a read after compilation of the class into the bytecode and reading the bytecode. It will load the JVM first, and then by the use of loader, it will load the class into the JVM, and then after execution of the program, that the JVM will be destroyed. This is how it starts. Okay, go to the next question. Where JVM is present in a setup. The JVM will be present in, it is as you can see in the diagram, JVM is a part of JRE. The JVM is present in the JRE, Java runtime environment, and Java runtime environment is present in the JDK. So this is the setup how the DLL or the binary will be present inside the installable. Okay. What are the memory parts of the JVM? Which memory area is shared among the thread? Which memory area is present in the thread? How are the memory area associated? I will explain this. I will do some explanation over here right now, which will cover all the four things. Okay. So okay, let's see how it is. Okay, so it shows how what will memory areas are being connected to JVM. Like the first question was what will memory parts of JVM. Now, so I have given the query part of JVM. Okay, so okay, so as you can see, method area is a part of JVM. Runtime constant pool you can see in the below in below you can see written this. This is the runtime constant pool is also a part of JVM. Heap is also a part of a JVM. And what else part is there? Thread. Thread is also a part. I have created this thread to signify that this JVM part, which this thread, it has four. It has okay. It has this four components present. Okay, like program counter, native stack, and frame. So this four memory area which has been are created within a thread. It can be main thread, it can be run thread, any thread, whichever it is running. It creates a memory stack within the thread, stack, frame, native stack, and program counter. So this present inside the thread. Okay, and this thread is being a part of JVM, or JVM is spawns the thread. Fine. And the part, so it has answered your question, like what are the memory parts you have given, which memory area are said on a thread, that is also given, and which memory area are present in the thread is also given. This shared part I will show. Shared is like this heap, like whatever is not been, whatever area, JVM area is not a part of thread is shared between the thread, like method area, runtime constant pool, heap area. So these three sections are being shared between the threads. How are the memory threads are associated to each other? This question you can find the answer in my previous video, uh, or you can just simply go to the relationship, like thread is there. Now when thread, like I'll go very fast over here, when the thread method is called from the thread, then a frame is created, frame name is created, and this frame is pushed into the stack, and then from the stack all the operations of the method is been called. Now here the program counter is there, which contains the instruction to be executed. Native stack is the same stack used for processing of the functions of the native code via the JNI interface. Okay, and heap and all, heap is this stores all the objects of the class. Okay, and heap has two parts, two memory area which contains which makes the heap. One is old area or tenure area, and another is young area. Okay, so this is how it has been interlinked. Fine. What are the type of loaders? Okay, so we will see what are the type of loaders. Uh-oh. Part of 1:10. Nope. Okay. Okay. So here it shows how it is interlinked. So it shows that class loader is there. The class loader has three types: application loader, bootstrap loader, and extension loader. These are the major three loaders which have been the type of class loader. It shows application and extension has the common parent bootstrap class loader, which is the main class loader used by the JRE to start up the JVM. Okay, and it loads the runtime environment rt.jar, i18.jar. Okay, and this .jar helps in starting up the JVM. So this three mainly the loaders are which have been used by the class loaders. Okay, then which loader resides in the software setup? Where the loader resides, and as all these three loader are present is a part of class loader, this class loader will be present inside, as you see in the earlier one. Or you go to this one loader. This is the class loader I am saying. This is the class loader. This class loader will be a part of JRE. So this class loader is present inside the JRE. Okay, there is an executable which is present in the JRE. So the JRE is responsible for doing the initiation setup. Loaders are related to each other. It is like I've said, the bootstrap is the parent of all loaders, and it helps in loading all the necessary code classes, and then the extension class needed to load the extension folder in the JRE, and the application to load the class or the byte of the compiled class of the main program which you are writing. Where are the objects present in the JVM memory? So the objects which are the instance of the class are present inside JVM. Okay, you know this. And where does the initialization happens? Okay, now this is a very interesting question where the people ask like why does the initialization happens? So it's like it happens when the class has been loaded into the JVM. Okay, now it happens when the class been loaded into the JVM during the load, linking, and init phase. This initialization phase is where the initialization happens. Okay, where linking happens. The linking happens either when the class is loaded in the JVM, and another is when the method is being called and this JVM frame, this frame memory which is part of the thread, this thread contain a dynamic link. Like it contains, if you go to my previous video, you will see how in details I have mentioned how the method reference or instance reference are there, which have been dynamically linked to the method area, either to the method area or of a particular class using the constant pool, right? Okay. What are the garbage collectors? What are the types of garbage collectors? So garbage collector, if you go here, like you can see there are majorly four type of garbage collectors, like parallel garbage collector, concurrent garbage collector, serial garbage collector, and G1C garbage collector. So these are mainly the primary type of garbage collector. Depending on the type of garbage collection happens, but you have to be little cautious or little bit very smart to use the garbage collector at the right place. You can't you are free to use any garbage collector, but this is not the way. You have to it is not the right way. You have to understand the situation and understand the scenarios when and where the garbage collection needs to be placed, right? On which area garbage collection happens, which part area memory area of JVM garbage collection happens. The garbage collection usually this garbage collection happens between on the heap memory area of the JVM, fine, created by the JVM. What are the part of the heaps? Okay, the heap, this is the heap. The heap is part of this relationship, is just part of, it is a part of old region and part of young region, fine. And this young region is also has three subparts, which is concept of Eden. It comes in step one. I'll leave the step one. You can understand like in order in which the garbage collection happens. It goes to our next question. The next question is like, what are the types of garbage collection event? So garbage collection event has three types. One is major type, one is full type, and one is minor type. So in minor type, whenever the minor type garbage collection event has been triggered, it operates on the young heap. Young heap, as you know, it composed of the hidden area, server area, and server 2 area. So these are the steps in which the collection happens. First is checks in the hidden area, then it goes to the server area, and then it checks for the area in the S2 area. If it is not, if the object which are not been which are able which are able to survive S2, these three regions will be promoted to the old areas. Okay, and full garbage collection happens on both areas, like young area as well as the old area or tenured area. What are the subparts of young area? I have showed you the subparts of young area: hidden area, survivor 1, survivor 2. Okay, on which part of the heap does different garbage collect? On which part of the heap does different garbage collection type operates on? Okay, I mean this is the same question, like it will be the full or minor measure which are operates on different types. Okay, so this different type or different events which are been initiated by the garbage collectors. So they are based on the event passed by the garbage collector. All this events has been triggered and it operates on the respective memory area of the heap. Fine. Okay, and there it comes. When an object gets instantiated, which specific part of the memory does it goes to? Like here, when the object get initiated, this is the object which which is the instance of class. It is allocated first in the hidden area, hidden memory area of the heap. Okay, so this is the first place where it get allocated. And how does the code gets loaded in the JVM? Now this is a very obvious question. When it is telling the flow. How does flow happens? The flow is like the coder creates the class, Java class, and then it compiles the class, and then it creates the bytecode. Okay. Now when you run the code for running the for loading this bytecode, you have to tell the JRE. Okay, when you give uh, when you give Java and space bytecode, then JRE first starts the JVM, and the JVM asks the loader to load this bytecode, and okay, and JRE will using the loader will load the bytecode to the JVM. Okay, and when the JVM gets started, it will create all these memory areas: JVM area, method area, constant pool area, and the main thread will have the method area of program counter, native stack frames. Based on the different parts of the bytecode, different area will be spawned. Okay, so this is how it is created, and when the object of this class is get created inside a class, that objects get pushed into the heap, but first it is pushed in the hidden area of the young heap. Then as and when the garbage collection of different type get executed on this heap, if the reference is found to be have a strong reference, then it survives, and eventually it goes like if the survival if the object need to be survived, or need it has been referred by several places, and it has been referred for more number of times, then it get promoted from hidden to survivor 1, then the survivor 2, or eventually to S2. In the case it has not been removed by the garbage collector, and it has been referred by several other codes in the program. Okay, and if it has not been referred, then it will be removed, or it will not be promoted to any of the like from median, it will not be promoted to S1, even, or if it comes to S1, it will not be promoted to S2. Similarly, for old area, it is a very heavy one. Heavy one, as in it contains all those old areas, old memory areas, or old objects which are being referred by the application. Its lifespan of the object is too big, so that object are present in the heap. Okay, and I have to tell that with every collection, with every garbage collection, garbage pause is also associated. So yeah, if you want to have your application run as a constant phase, and it with less hang, or like such that it will run smoothly, then you have to make sure we use the right collector such that garbage pauses are very less. Okay, so that part I will discuss in details in the next video. For okay, I hope this will help you in preparation, or getting the idea how the JVM and how the components are interlinked with each other. Thank you.